All right, so previously we talked about what current is, kind of defined it, gave a little picture. Here's a little picture of what voltage is. And so voltage is basically a measure of the amount of energy that I have available per unit charge. Energy to move charges around in other words. And so if I have this region of space is sitting at 10 volts, let's say, then there's going to be some force acting on electrons in the nearby space, exactly like we kind of defined previously when we were talking about electric fields. And then this arrow is just showing which way these electrons are going to flow as a result of the voltage that I have at this point in space. We're going to talk a little bit more about different voltages, differences in voltage at different points in a circuit. We're going to talk about how voltage and current and resistance are related in the videos pretty much immediately following this subsection. But for now, all you really need to know is that voltage is the electromotive force, like it says here, and that force that we're talking about is simply the force that's pushing these charges around our circuits. We haven't seen any circuits yet. I think this actually might become clearer once we see a circuit. But if we have more voltage here, so I said 10 volts to start, but if I had even more voltage here, then there would be an even stronger force. This arrow, I could draw it maybe even bigger. An even stronger force pushing electrons through my circuit, or charges through my circuit. And since this video has been pretty short, maybe I'll just go ahead and tack on resistance while we're at it. And so this is the last one to define here is what is resistance. So here I've drawn a little piece of a conductor or some wire. You can think of it as a little cylindrical chunk of wire. And again, like I said, resistance is related to conductance in that they are inverses of one another. So my wire here has some length, L. It also has some area, A, some cross-sectional area. That would be the area of this circle here. And those two things are purely geometric aspects of the wire. It has a third aspect that we can't really see from this picture, but it would depend on what material this is. What material do we have here? And the third thing here is it's called resistivity. It's given by the Greek letter rho, which looks a little bit like a lowercase p, at least when I draw it because I don't write in Greek. But the resistivity gives us a measure of how resistive that material is, and the units are ohms times meters. And so if I wanted to find the resistance of this little chunk of wire, there's a simple equation for that. It would be that the resistance is equal to the resistivity in ohm meters multiplied by the length in meters divided by the area, the cross-sectional area of that section of conductor, which would be given in meters squared. And so you could see that my meters, and my meters squared cancel, and I'd be left with units of ohms for resistance. And so, again, we're not typically going to be looking at the length of the conductor. We're going to assume that our wires are ideal and that they have no length. And we're not going to be looking at the area. We're going to assume that they're infinitely large area, which means that they are infinitely conductive. And so, but just to let you know what the resistance really is, it's a measure of how resistive the wire is. You know, if the wire were longer, then, and this number were to go up, length were to go up, then the resistance goes up. If the resistivity of the material were to go up, then this number would go up. If the area were larger, that would mean that I have a larger cross-sectional area here, something maybe like much bigger. That would allow more charges to flow through, so my resistance would go down. And so, yeah, that's pretty much it for the definitions of resistance, voltage, and current. These are, again, the three quantities that we're really going to be looking at when we analyze DC circuits. specifically resistive DC circuits, which is the beginning part of this class, probably the first half. And there's a law that you may or may not have heard before. It's called Ohm's law. And it's the law, it's slash formula. Oops, that's pretty ugly. It's the law slash formula that relates current, voltage, and resistance. And it is going to be vital as we move through this class that you understand Ohm's law, that you understand how to use Ohm's law to your advantage to solve circuits. And in the next video, I think I even left myself a little note for you. Yes, that this is a perfect time to go and watch the video on experimentally proving Ohm's law. And in that video, I am going to do some experimentation and show you exactly what Ohm's law is. And I'm not going to do it in this video. I'm going to do it in the next video. But I'm just going to wrap this one up right here. And please proceed to the video on experimentally proving Ohm's law.